Hello all, we're glad to have you with us. I'd like to introduce Gary Messing. Dr. Messing is Distinguished Professor Emeritus of Ceramic Science and Engineering at the Pennsylvania State University. But for this purpose, more importantly, he is the Editor-in-Chief of Journal of Materials Research. Gary, please get us started.
This morning or this afternoon, wherever you are in the world, we are being joined by Dr. Benoit Merle. Benoit and his colleagues have co-guest edited the focus issue on advanced nanomechanical testing. Before we get into discussing the particular focus issue with Dr. Merle, let me first introduce each of them. So Dr. Merle is a professor at the University of Erlangen-Nuremberg, located in Erlangen, Germany. His fellow guest editors who will not be with us today are Verena Meyer-Keener. She is at the Department of Physical Metallurgy and Materials Testing at Montana University in Leoben, Austria. Timothy Rupert. He is professor of Department of Material Science and Engineering at University of California, Irvine. And Professor George Farr, who is at Department of Material Science and Engineering at Texas A&M in College Station, Texas. Benoit, we are really thrilled to have you conclude the editing of this particular focus issue. The area of nanomechanical testing has been at the forefront of the Journal of Materials Research since its founding, actually. Many of the seminal papers are located at JMR. And we are very thrilled with the fact that you and your guest editors have done an update on that particular discipline. To get us started, could you tell us a little bit about what motivated you and your guest editors to propose a focus issue in this area?
So, thank you very much, Gary, for inviting me. So to answer your question, I have to say that it all goes back to my time as a PhD student. Back then, JMR was probably the journal I was reading most because it contained almost all of the seminal papers related to my field, nanoindentation testing and nanomechanical testing. At that time, I was especially struck by the high quality of those papers. They actually also turned out to have a very high impact, and quite a number of them received a fairly high number of citations. So I'm aware, and most likely as the editor-in-chief of JMR, you must be aware that at least 4 of those papers related to nanoindentation gathered at least 1,000 citations, which is really a lot. And as far as I can remember, the highest cited one, the Oliver Farr paper, has around 20,000 citations, which compares well, I think, with the 3 or 4 best cited Nature paper of all time. So that tells you how impressive JMR was for me. And back to that time, I would never have dreamed of becoming an editor of such a highly respected journal as JMR. So that's for the fun part. And then I have to say that especially those special issues were very influential, not only for me, but also for the whole community, because they provided a unique opportunity to have a condensed view over the evolutions in the field. And you know that nowadays people are hardly ever reading journals. At least we are looking for papers through search machines. But special issue of JMRs are actually the only journals that we were reading from, or that we probably are still reading from the first to the last word. So that tells you how highly qualitative and highly helpful they are to follow the evolutions in the field. And then on the personal level, I have to say that the 2012 focus issue on nanomechanical testing was the first opportunity I had to publish a paper about nanoindentation. So that was very influential for my own career. And fun fact, this first paper was written together with Verena Meyer-Keener, who is now my co-editor for this special issue in June 2021. A few years ago, we realized, Verena and myself, that there hadn't been any focus issue published since 2012. And we were really nostalgic about those times. And as a service to the community, we proposed to renew, to revive this tradition. And that's basically what led to the current special issue.
Very nice, Benoit. There's no question that I think this is now the kind of the fifth review of the status of the field, being 9 years since the last one in JMR. This is certainly an important time for the discipline. Even as an outsider myself, I'm amazed at how many papers go back to the original War and FAR papers, and the large number of papers that continue to come through. Certainly the focus issue you have already guessed at is impressive. You're over 36 papers already. We'll finalize at maybe 38 papers. Could you tell us a little bit about what are some of the major themes that came through as you pulled together this particular focus issue?
Is that we can definitely say that nano-indentation is back. Actually, some of my colleagues were talking earlier with me of a revival, and that has been confirmed by this focus issue. I'm a bit skeptical using the word revival, because obviously nano-indentation has never disappeared. That's remained very dynamic through the years. However, if we had been talking about this 10 to 15 years ago, I would have personally been convinced that the new techniques that we were developing at that time, and that were based on focused ion beam milling for preparing the sample and producing microsamples out of the surface. We call these nanomechanical testing techniques that are enhanced by FIP. Well, at that time, 10 to 15 years ago, I would have been convinced that those methods would supplant nano-indentation and make it obsolete. That didn't happen for a variety of different reasons. One of them is, of course, that nano-indentation is very cost-effective. FIP milling costs around $100 an hour, so you won't be able to produce that many samples. The second factor is that progress has been made in the field of nano-indentation over the past years, so that it is now possible to test many more material properties, mechanical properties as earlier. So that makes it sufficient for a large number of investigations, and there is no need to resort to the more expensive micromechanical testing techniques. And last but not least, one reason that became obvious to me with this focus issue is that nano-indentation is definitely one and the only scalable method regarding small-scale nanomechanical testing. And with that, I mean that it's possible to use nano-indentation as a high throughput method. It's possible to make thousands of indentations within a few hours and use this data as a basis for data science analysis. That's what a number of our authors have done in the focus issue. And they use this technique to derive physical knowledge from the material. So that's one way to do it. The other way to do it, which is roughly used by the other half of the authors, is to combine nanomechanical technique with some analytical measurements, ideally in situ, so that they are able to observe the deformation and to conclude which deformation mechanisms are active. But that's, of course, more expensive. Finally, the last trend that I have evidenced is that all the techniques, be it nano-indentation or nanomechanical testing, are actively being developed, and they are expanded towards conditions that are more relevant for applications. So this includes, for instance, testing at non-ambient conditions, or using very high velocities to reproduce the mechanisms that are active during an impact, for instance. All this has not been possible in the past years due to strong technical limitations, and we are currently working, and good progress is being made in this field to access those properties and use them to further support developing new materials.
Oh, very, very interesting, Benoit. You know, in reading through the introductory article that you wrote with your colleagues, I was struck by one thing, and it elicits then a question. The one thing I was struck by is that there is now finally, and I think it's called an ISO standard for testing of metals, I believe. It seems that we could use some more standardization of the testing, as I've seen so many papers come through where there seems to be some misunderstanding about how to properly use these nanotesting techniques and to collect the data in an accurate way to get realistic properties. Would you like to speak a little bit about what you see as some of the trends that would help young researchers to see things that would be able to, that they can do to make an impact on the future of nanomechanical testing?
Mm-hmm. You're absolutely right, Gary. So the ISO norm 14577 about nanoindentation was an important milestone. It's basically what was needed to get the techniques from the lab into the industry. So it's currently actively being used in the semiconductor industry and other industries to characterize small elements, coatings, and basically all elements from different microstructures. So that's one aspect. I'm certainly in touch with some colleagues in the industry, but I'm more specialized in fundamental research. So about fundamental research, the trends are obviously depending on the overarching goals of the community of science. Because in the nanomechanical community, we are basically providers that offer to support the development of new materials. What we can offer, what we do offer, is to characterize the mechanical properties of elements of microstructures, of new coatings that are otherwise not accessible. We are not developing ourselves new materials. So in that regard, we depend upon the orientations of research in those other fields. So what could those other fields be for the next 10 to 20 years? So obviously that will depend on the societal challenges. So because of the corona crisis, we might have forgotten a little bit about this, but last year or 2 years ago, global warming was the main challenge in the media, and that's certainly not something that's going to go away. So that's something that governments are going to address through technical mitigation procedures. And one of them that concerns us is probably the development of better materials that have a higher yield and that are more durable. And that's certainly an area where we can support. So to that aim, we probably need to do more testing in non-ambient conditions. So energy materials will require an elevated temperature environment. And in order to make coatings more durable, we need to understand what's happening upon impacts, for instance. Those are a few directions that would come on top of my mind, but I'm no prophet in that field.
Well, very, very good, man. And none of us are prophets. We do our best. I am struck by one thing, though, and that is that nanomechanical testing has become so sophisticated that it is now within the scheme of doing like electron microscopy and OJ spectroscopy and other very detailed kinds of investigations that normally require collaboration amongst various disciplines. So as you suggested earlier, the big data group, for example, they are looking for interesting problems, and certainly nanomechanical testing brings big data. And so there's an obvious collaboration for the future The in situ measurements brings collaboration with people who do design of equipment and how to do the analysis with taking into account all of the various parameters that now have changed as you go to different environments, whether temperature or atmosphere or whatever. So I can see that the field will expand dramatically with collaborative research, and that everybody working in nanomechanical testing is sure to be working with somebody in the future to make new advances on the application in mechanical testing and the creation of new materials, as you said, for solving important societal problems like global warming. So, Benoit, thank you so much for joining us. I'm just thrilled that you and your colleagues have put out through an incredible amount of work to pull together this particular focus issue. I think it would stand on its own amongst the best focus issues that certainly we have done, but it also does justice to documenting the discipline and where it is today so that people can look at it to see, number one, what things they should be paying attention to, but also looking at, well, where are the opportunities for the future? So again, Benoit, thank you again for joining us today. All the best for you in the success of your own research and for those of your colleagues. Again, thank you again for pulling together such a special issue for us in Journal of Materials Research.
Well, thank you very much, Gary. Before we close, I'd like to acknowledge the support from my co-editors, Tim, George, and especially Verena, who has given birth to a boy last week named Lauren. So thank you very much for your commitment and your support in that endeavor. And thank you to you, Gary, for this interview and your support during the whole focus issue process.
Yeah, very nice. Benoit, thank you so much. I look forward to meeting you sometime in person, maybe a future MRS meeting someplace else in the world.